Hi folks, Dr. P here. This is Math 10C, Exponents and Radicals, and this will be a review of the exponent laws. So these are the exponent laws that we need to be familiar with, taken from the workbook. And I'm going to quickly go through the exponent laws and I'm going to give you some examples. First exponent law is the product law. This is when we're multiplying two powers where the bases are the same. So here the base is a in both of the powers, which means that the exponents, m and n here, can be added together. Okay, the key thing to remember is that we need to have the same base. And if that's the case, then we add the exponents. The second exponent law is the quotient law. It's similar to the product law in that when we're dealing with powers that have the same base, so here the bases are a, but now we're dealing with a quotient, this will allow us to subtract the exponents. But again, we need the same base in order to subtract the exponent. The next is the zero power law. And it simply states that a power where the exponent equals to 0 always equals to 1. It doesn't matter what the base is. Power of a power law. So now we have a power, a to the power of m, that is in turn a base with another exponent. So a to the power of m, we put the whole thing in brackets, to the power of n, so power of a power. This will allow us to multiply the exponents in order to simplify this expression. Power of a product. So now we have a product, a times b, raised to a power. This can be represented by applying this exponent to each of the terms in the product. So it's going to be a to the power of m times b to the power of m. Power of a quotient. So we have a quotient, in this case a divided by b to the power of m. This can be represented by applying the exponent to each of the term in the quotient. So m is applied to the numerator, m is also applied to the denominator, and we're going to get a to the power of m divided by b to the power of m. And finally, we have the negative exponent law. So if you have a power with a negative exponent, so a to the power of negative n, we can write this as the reciprocal of the power with a positive exponent. So what it means is that we drop the negative sign, so this negative sign in front of the exponent disappears, and then whatever remains, which is just going to be a to the power of n, is moved downstairs in quotient. Okay, now this goes both ways. So one way of expressing this is that the negative exponent law, when we're applying it, we drop the negative sign in the power and move the remaining power across the division line. So in this case here, it's going to be moved downstairs in the denominator, but we could also have a scenario like this. If we have something like this, 1 divided by a power where we have a negative exponent. We can do the same thing here. We drop that negative sign in from the exponent, and then we move the remaining power across the division line. So in this case, it's going to be moved up into the numerator. So we're going to be getting a to the power of n. You can write it like this, or this is the same thing as a to the power of n over 1. Usually we would not write it like this. We would simply write it like that. Right? So I'm going to do a few examples here for each of the laws. So the first one is the product law. And so here we're dealing with powers that have the same base, so x cubed times x to the power of 4. We have the same base, which will allow us to add the exponents. So it's going to be x to the power of 3 plus 4, which is equal to x to the power of 7. Exponents can also be negative. So for example, we can have b to the power of negative 3 times b to the power of 5. We check that the bases are the same. They are. That means, and they're multiplied, the two powers. So that means we can add the exponents. So it's going to be negative 3 plus 5. Negative 3 plus 5 is positive 2. So it's going to be b squared. Okay. Let's look at the next exponent law, the quotient law. So we have a quotient, so x to the power of 4 divided by x squared. So again, we need to have the same base. The base here in the numerator is x, the base in the denominator is x, which means we can apply the quotient law. We can subtract the two exponents, so it's going to be x to the power of 4 minus 2, which equals to x squared. Here's another example. We can have, if we're dealing with negative exponents, so we can have x to the power of negative 2 over x to the power of 6. The bases are the same, so we can subtract the exponents. It's going to be negative 2 minus 6 equals to x to the power of negative 8. Okay, let's have a look at the zero power law. So if we, for example, have a power that's just z times z to the power of negative 1. Okay, so the first power here, it just says z. If we don't have an exponent, it means the exponent is 1. So we're multiplying two powers. We have the same base. We're going to use the product law here. So z to the power of 1 plus negative 1. Well, plus and minus becomes minus. So this actually says 1 minus 1. You can rewrite it like this to be clear. Z is to the power 1 minus 1, which equals to z to the power of 0. Anytime we have a power where the exponent is 0, the power always equals to 1. Next one is power of a power. So let's do an example where we have n squared. So that's our power. And then the power has another exponent on the outside of these brackets. So the power is cubed. Okay, power of a power will allow us to multiply the exponent. So it's going to be n to the power of 2 times 3, which equals to n to the power of 6. If we do the same thing with negative exponents, we can have n to the power of negative 4, and then to the power of 3. So we multiply the exponents. Because these exponents are negative, we want to put them in brackets. So negative 4 times negative 3. If you multiply two negative numbers, the answer will be a positive number. So negative 4 times negative 3 is going to be n to the power of 12. Let's look at the next one, power of a product. So we can have a scenario where we have a times b, and then it's squared. So in the power of a product law, we would apply this exponent here, the 2, onto each of the terms in that product. So it's going to be a squared times b squared. We can also have a scenario where we have n squared. So one of the terms in the product has an exponent other than 1. So n squared times m, here's a product. And then cubed. Same sort of thing. We're going to apply the 3 to each of the terms in here. So what we're going to do here is we have n squared, and that's going to be cubed. And then we have m cubed. And now we may recognize that this expression here can be simplified by using the power of a power up here. The power of a power law right here. Okay, so if we do that, we're going to apply the power of a power law here, which means we're going to multiply the 2 exponents, so n to the squared times 3. So from here to here, we use the power of a power law. And then we just have m cubed, and then n, so 2 times 3 is 6, n to the power 6 times m cubed. Let's look at the power of a quotient law. So we can have a quotient that is a over b. Now these brackets here are necessary, because if we don't include those brackets and the rest remains the same, it's going to mean something else. So in the power of a quotient law, we're going to take the exponent, we're going to apply it to each of the terms in the quotient. So we're going to get a squared divided by b squared in this case. If we have a scenario where we have, say, n squared over m as a quotient, and then that is cubed, we're going to do the same thing. We're going to apply this outside exponent 3 to each of the terms. So we're going to get in the numerator n squared, and it's cubed, over m cubed. And now we can see that in the numerator, just like in the previous example with the power of a product law, we now can apply the power of a power law here. So it's going to be n to the power of 2 times 3 over m cubed. So we're going from here to here in the numerator by applying the power of a power law. And then to simplify it completely, we just multiply the 2 and the 3, so it's going to be n to the power 6 over m cubed. Now this is your final answer here. Do not make the mistake of applying the quotient law here. Remember that in the quotient law, when we have a quotient like this with a power upstairs and a power in the denominator, we can subtract the exponents. Here, the bases are not the same. The base in the numerator is n. The base in the denominator is m. So we cannot use the quotient law here. This will be our final answer. This cannot be simplified any further. So that was the power of a quotient law. And then finally, let's have a look at the negative exponent law. So we can do an example like a to the power of -4, and we can multiply that by a to the power of -1. So we have a product of two powers where the bases are the same, both bases are a, which means we can use the product law. So it's going to be a, and then we add the exponents, so -4 plus -1. Positive times negative is negative, so this is the same thing as a to the power of -4 minus 1, which is a to the power of -5. Anytime we're simplifying exponents, we never want to leave a power with a negative exponent in the answer. So this would not be completely simplified. We need to get rid of the negative exponent. And the way to do that is by using the negative exponent law. So we drop the negative sign in front of the exponent and move the remaining power across the division line. So in this case, it's going to be moved downstairs into the denominator, and we're going to be left with 1 over a to the power of 5. That's going to be our final answer. And I'm just going to put a note here. We can never leave negative exponents in final answer. When you're asked to simplify powers using the exponent laws, make sure that you do not leave a negative exponent in the final answer. If you end up with a negative exponent, you have to use the negative exponent law to get rid of it. Okay, so here's another example using the negative exponent law. If you have a scenario such as 1 over x to the power of -2, again, we have a negative exponent here, and we can use the negative exponent law to get rid of it. We drop the negative sign in front of the exponent, so get rid of that negative sign, and move the remaining power, which is just going to be x squared, across the division line. So in this case, it's going to be going upstairs into the numerator. We're going to get x squared over 1, which is the same thing as x squared. Right, folks? That's a wrap. Until next time, stay safe, stay healthy, and may the math be with you. See ya.